All right, today we're diving into a real cosmic cold case. This is a mystery written in starlight, and it seriously challenges everything we thought we knew about how galaxies are born and how they die. So take a look at this. Our main suspect is this faint little smudge of stars right here. It's a galaxy called Holmberg IX. And it's only about 12 million light years away from us, over in the constellation Ursa Major. In cosmic terms, that's practically our next-door neighbor. But don't let that fool you. This little galaxy is hiding a huge secret. And that secret, it really just boils down to one huge question. When we look at Holmberg IX, are we watching a brand new galaxy being born? A cosmic infant taking its very first breath? Or are we looking at a ghost, a galaxy that's already failed and is just fading away into nothing? The crazy part is, the evidence? Well, it points in both directions at once. Okay, so to get to the bottom of this, we've got to figure out why this galaxy is so weird. And our investigation really starts with just how ghostly it is. All right, so on paper, Holmberg IX is what we call a dwarf irregular galaxy. It's basically this tiny little companion galaxy that's orbiting the absolutely colossal spiral galaxy M81. I mean, look at the scale difference here. It's like a tiny rowboat floating next to a giant aircraft carrier. But just calling it a dwarf galaxy doesn't even begin to scratch the surface of how strange this thing is. And this is what I'm talking about. This really shows off Holmberg IX's bizarre dual personality. Check this out. On the left, you're seeing it in ultraviolet light, and it's just ablaze. It's a beacon shining with the super intense light of young hot stars. But then, look to the right. This is in the normal visible light that our eyes see, and poof, it almost completely disappears. It's a ghost. So what is going on here? The first clues, funny enough, aren't even inside the galaxy itself. They're hidden in the totally chaotic history of its neighborhood. We have to go back in time to the scene of a truly epic galactic pileup. So picture this. A few 100 million years ago, this whole area of space was just a mess, a colossal gravitational pileup. You had these three big galaxies, M81, M82, and NGC 3077, all doing this chaotic dance, having a bunch of super close encounters. And these weren't gentle passes, these were violent interactions that literally ripped huge streamers of gas and stars right out of the galaxies, scattering cosmic wreckage all over the place. But here's the cool part. This is where destruction leads to creation. Because in all that chaos, all that stripped away material, well, it can actually start to clump together, collapse under its own gravity, and form brand new, smaller galaxies, literally recycled from the debris. And that brings us to our number one suspect for what Holmberg IX really is, something called a tidal dwarf galaxy, or a TDG for short. Now, unlike a normal galaxy that forms from the universe's original gas, a TDG is more like a second-generation galaxy. It's born from the guts of other older galaxies. And guess what? Holmberg IX is sitting smack dab in the middle of a stream of gas that connects M81 and its neighbors. The location? It's perfect. So is Holmberg IX really a newborn TDG? I mean, the circumstantial evidence is pretty darn strong. So now, let's dig into the forensics and see if this theory actually holds water. First up, let's talk age. When astronomers looked at the stars inside Holmberg IX, they found something amazing. Most of them are super, super young. We're talking less than 200 million years old. And that timing? That is not a coincidence. It lines up perfectly with that big galactic collision we just talked about. In fact, check out this quote from a major study back in 2008. It says Holmberg IX has the youngest mean stellar population age of any nearby galaxy. Think about that. It is, for all intents and purposes, the youngest galaxy in our entire cosmic neighborhood. It's a literal newborn, still glowing from its recent birth. Okay, clue number 2 is how its stars are arranged. The young stars, they're all clumped together, right in the center, forming the actual core of Holmberg IX. But the few older stars they found floating around, they're just scattered randomly. And the closer you get to the big galaxy M81, the more of them you see. So what does that tell us? It tells us they aren't really part of Holmberg IX at all. They're just background noise, part of M81's huge extended halo. All right, for our final piece of evidence, we're going to do a kind of cosmic DNA test. We're looking at a galaxy's metallicity. Now, that's just a fancy astronomer word for how many heavy elements it has, anything that isn't hydrogen or helium. And just like a DNA test, it can tell us all about its parentage. So a normal dwarf galaxy that formed all by itself should be really metal poor, like only 1/20th the heavy elements of our sun. But Holmberg IX? It's way, way richer. We're talking up to 1/3 of the sun's metallicity, and its chemical signature? It's a dead ringer for the stuff you find in the outer disk of its giant neighbor M81. So it's a recycled galaxy. Case closed, right? Well, not so fast. Just when it looked like we had it all figured out, recent studies have thrown a massive wrench in the works. They've uncovered a bunch of paradoxes. It turns out Holmberg IX's infancy is a whole lot more puzzling than anyone thought. Look, the evidence for it being a young tidal dwarf galaxy is solid. I mean, it's really compelling. But newer, deeper observations have found these major contradictions in its basic chemistry that just don't add up. They make no sense if this is supposed to be a normal, young galaxy busy making stars. Okay, so here's puzzle number 1. This galaxy is absolutely swimming in fuel for making stars. It has a mind-boggling gas to stellar mass ratio of over 40-1. That is a huge tank of hydrogen gas, but it's missing a crucial ingredient. Dust. You see, dust grains are like little shelters that let gas clouds cool down and collapse to form new stars. Without dust, it's really hard to get star formation going, and Holmberg IX has basically none. And this is the question that has astronomers scratching their heads. Metals and dust are supposed to go together because dust is made of metals. You know, the heavy elements cooked up inside stars. So how can it be rich in metals but poor in dust? It's a huge contradiction. It's like finding a forest full of trees, but with no soil anywhere. And the mystery just keeps getting deeper. With all that gas, all that fuel, you'd expect Holmberg IX to be a roaring stellar nursery, just cranking out new stars left and right. But it's not. In fact, its star-making factories have, for some reason, completely shut down. Yeah, take a look at this chart of its star formation history. It shows exactly what went down. See that first big burst? That was its initial intense phase of star making, about 130 to 200 million years ago. And then, look at the second bar. Nothing. For the last 80 million years, it's made almost no new stars. It's a galaxy full of gas that has been mysteriously quenched or shut off. So, what happens to a baby galaxy that just stops growing? Well, there are 2 likely paths it could take. First, it could just slowly shrink and fade away, turning into a dim, compact ball of old stars, what we call a dwarf spheroidal galaxy. Or second, without the gravitational glue that active star formation provides, it might just fall apart. It could completely dissolve back into the void, with its stars scattering into a faint, forgotten stream. And that brings us right back to where we started, staring at this ghost. It really is a cosmic infant. But it's an infant that has already gone quiet. What we're seeing is a glimpse of a galaxy that was born out of complete chaos. But now, it looks like it might not even survive its own mysterious childhood. The really strange case of Holmberg IX just goes to show you. The universe is full of things that just don't fit into our neat little boxes. And it leaves us with one last, really tantalizing thought. How many other cosmic ghosts like this are out there? Hiding in the wreckage of ancient galactic crashes, just waiting to completely rewrite the story of how galaxies live and how they die.